Wednesday, April Fool's Day, April 1st. I hope you guys are all well, washing your hands and doing fun little tricks and jokes and pranks on your family members that you're sheltering in place, as long as they're fun and not harmful. Anyways, today is about evidence of change over time. There is a whale video that shows kind of the wrap up to the activities that we've been doing around the whale, the evidence of the whale, like the comparative anatomy and the DNA that and the embryology that we did this week. And then today's bulk of the time is going to be spent on your foldable, the bottom flap of evidence of change over time. On the slide, you'll see a bunch of links to the PDFs here. And so the first one that you're going to see is around the graphs. The extinction date graphs given to you. You have some questions, and then the information here you'll have to read, and it will definitely help you. So if we go back to this, I've given you, just as usual, a daily slideshow now. And now that we're back into our habits of practice around how we taught class, I will keep your interactive notebook table of contents updated. This is the slide for you, and you'll see all the links for everything, but you're going to describe what a mass extinction looks like on this graph. Why would the number of families be a good indicator of biodiversity in the fossil record? And then you'll jump over here to populations over time. I just showed you the link for the extinction date graphs, and I'm going to show you evolution, common ancestry, and anatomy pages. You'll notice that these right here are a lot of review, so you may not have to read everything. Evolution doesn't happen to an individual, it happens to a whole population. So notice the title of that top right hand corner of your foldable, Populations Over Time. What does it have to do with evolution? Common ancestry is shown here through use of the DNA. That looks like the painting behind Mrs. Bombardieri every time that she's lecturing. I love that picture. The next one here talks about common ancestry from embryos. The next one here talks about similarities and differences with evolution, common ancestry, and if you scroll all the way down here, you will then see similarities of an anatomy. And then right here, common ancestry from fossils. Not only do we use DNA, embryology, and comparative anatomy, that's all boiled down to the fossil record as we look for change over time in these populations to show that one species evolves into two or more species, called speciation. I hope you guys have a great day. Spend your time working on your foldable, and I will see you tomorrow in office hours. Miss B is online today if you need help through any of these questions on your bottom flap. Happy April Fool's Day.